Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. Hey everyone. Welcome back to Structural Design Only, a channel with different vision. I am PS Chatterjee with you. This is episode 17 in our series on building with concrete, and today we're diving into formwork, based on IS 456. Whether you're a civil engineer, contractor, or just interested in concrete, this video will equip you with valuable knowledge. So, get ready to think about the best formwork for your RCC structure. Watch the full video and let's ensure high-quality formwork together. Now the question is, what is formwork? Formwork sets the stage for rock-solid concrete structures, and it focuses on the temporary molds that shape the poured concrete. Here's the key takeaway: formwork must be strong and leak-proof. It should hold its shape during concrete placement and prevent that valuable cement slurry from escaping. For specifics on design and construction, we can refer to IS 14687. Remember, proper formwork is the foundation for a safe and long-lasting concrete building. Clause 11, Formwork Removal Flowchart. This slide presents the flowchart for Clause 11 of IS 456-2000, a key guideline for safe formwork removal in concrete construction. The flowchart starts with Clause 11.1, Clause 11.2, and Clause 11.3. Clause 11.3, further divided into three subclauses: Clause 11.3.1, 11.3.2 and 11.3.3. In my upcoming slides, I will discuss each clause separately. If you found this explanation helpful, I'd be grateful if you'd consider giving the video a thumbs up and subscribing to the channel for more informative content on civil and structural engineering. Leaving a comment in the section below is always a bonus for me. It costs nothing, but it helps tremendously to know I'm on the right track. Alright everyone, let's get more specific about Clause 11.1, we may call it the formwork foundation. This clause sets the stage for strong concrete by focusing on two things: strength and preventing leaks. The formwork needs to be rigid during concrete placement and prevent that valuable cement slurry from escaping. Now, this slide dives into something called tolerances. These are basically the allowable variations in shapes, lines, and dimensions of the final concrete elements. For example, the deviation from the specified cross-section of columns and beams can be a maximum of 50 mm positive, thicker, or 12 mm negative, thinner. Eccentricity, 0.02 times the width of the footing in the direction of deviation but not more than 50 mn, and thickness, plus or minus 0.05 times the specified thickness. There are also tolerances for eccentricity in footings and thickness of concrete elements. These tolerances are in place to ensure the final concrete structure meets the design requirements without compromising its strength. It's important to note that these tolerances apply only to the concrete dimensions, not the positioning of vertical reinforcing steel or dowels. For the super specific details on design and construction, we can refer to IS 14687. Remember, following these guidelines is crucial for achieving strong and durable concrete structures. Clause 11.1 is essential, but there's more. Next slide, we explore Clause 11.2 and Clause 11.3. Alright everyone, let's move on to the next stage, Clause 11, formwork, but this time we're focusing on Clause 11.2 and 11.3. Clause 11.2 emphasizes the importance of preparing the formwork before pouring concrete. Imagine your formwork as a mold for your concrete. You wouldn't bake a cake in a dirty pan, would you? The same principle applies here. This clause requires removing any debris like chippings, shavings, or sawdust from inside the formwork. A clean surface ensures a smooth concrete finish. Next, Clause 11.2 talks about treating the formwork with a release agent. Think of it as a non-stick spray for your concrete mold. This helps the concrete easily separate from the formwork after it sets, preventing damage to the finished surface. Now, let's take a quick peek at Clause 11.3, stripping time. This clause highlights the importance of letting the concrete cure properly before removing the formwork. Here's a key point: the formwork shouldn't be removed until the concrete reaches a specific strength. This is typically twice the stress the concrete will experience at the time of removal. Why is this important? Imagine removing the mold from a cake before it's fully baked. It would crumble. Similarly, weak concrete can't support itself without the formwork. Clause 11.3 doesn't specify an exact time for stripping, but it emphasizes the importance of concrete strength. Now, Clause 11.3 actually dives even deeper with three sub-clauses: 11.3.1, 11.3.2, and 11.3.3. We'll explore these in detail in the next slides. Now let's zoom in on Clause 11.3.1, striking formwork. As we saw earlier, Clause 11.3 emphasizes waiting for the concrete to reach a certain strength before removing the formwork. Clause 1.3.1 gets even more specific, providing a guideline for stripping time based on normal ambient temperature, typically around room temperature, and ordinary Portland cement. Let's take a closer look at this table. The first column with serial numbers helps us easily reference each entry. The second column, titled Type of Formwork, specifies the different types of formwork for which the stripping time is provided. Now, the key information lies in the third column, Minimum Period Before Striking Formwork. This column tells us the recommended minimum waiting time before removing a specific type of formwork. For example, look at row A, vertical formwork for columns, walls, and beams. This type of formwork typically needs to wait between 16 to 24 hours before removal. Moving down the table, we see entries for soffit formwork for slabs and beams, rows B and C. These typically require longer waiting times, with props needing to be refixed after removal. Now, things get a bit more specific with rows D and E here. The stripping time depends on the span of the element being supported by the props. For instance, props supporting slabs with a span of up to 4.5 meters, row D1, have a minimum waiting time of 7 days. This waiting time increases to 14 days even for spans exceeding 4.5 meters, row D2. Similarly, props supporting beams and arches follow the same principle. Spans up to 6 meters, row E1, require a minimum wait of 14 days, while spans exceeding 6 meters, row E2, need to wait for 21 days. Important note: remember, this table is a general guideline. As Clause 1.3.1 mentions, factors like lower temperatures or other cement types might necessitate adjustments to the stripping time. Clause 11.3.2, leaving the right support behind. Imagine you've baked a delicious cake. You wouldn't remove the pan while it's still hot and wobbly, would you? The same principle applies to concrete. Clause 11.3.2 focuses on what happens after you remove the main formwork. It's like ensuring you leave the right support behind for your concrete structure. This clause says two things. Number and size of props: there should be enough props left under the concrete element, beam, slab, or arch, after removing the main formwork. The size of these props also matters. They need to be strong enough for the job. Carrying the load. Together, these remaining props should be able to safely carry the weight of the concrete itself, dead load, and any temporary loads, live load, that might occur while the concrete cures or during further construction. Think of these props as temporary guardians, supporting the concrete until it gains enough strength to stand on its own. Clause 11.3.3, Reentrant angles and early removal. Now, picture a formwork with sharp corners that jut inwards. These are called reentrant angles. Clause 11.3.3 talks about these specific cases. Here's the key point: concrete with reentrant angles can be more prone to shrinkage cracks. These cracks happen as the concrete dries and shrinks. This clause recommends removing formwork with reentrant angles as soon as possible after the concrete has set, not before it's strong enough. Why? By removing it early, we reduce the restraint the formwork imposes on the concrete at these sharp corners. This helps minimize the risk of shrinkage cracks. Remember, safety always comes first. Never remove formwork too early if the concrete isn't strong enough. These subclauses within Clause 11.3 highlight two important things. Leaving proper support after removing the main formwork, Clause 11.3.2. Removing formwork with reentrant angles as soon as possible after the concrete has set, Clause 11.3.3. Thank you for watching this commentary on Clause 11 of IS 456-2000. I hope you found this explanation helpful. My next video will explore Clause 12, Assembly of Reinforcement. My channel has tons of civil engineering content, design of slabs, beams, columns, etc., steel columns, theory explained, and Excel calculations. Subscribe for more. Watching the full video and subscribing to my channel helps me create even more content that you'll find valuable. If you have any questions, leave a comment below, and feel free to share.